Hello students, today we are going to solve problems on conservation of mechanical energy. Before we begin, let's quickly revise our last lesson. For a falling body, at the highest point, the body possesses only potential energy because its velocity is zero. Since velocity is zero, the kinetic energy is also zero. As the body begins to fall, the potential energy is gradually converted into kinetic energy. This means that at intermediate points, the body possesses both potential and kinetic energy. Finally, when the body reaches the ground, where the height becomes zero, the body possesses only kinetic energy. Since all the potential energy has been converted. Example 1. A body of mass 2 kg is dropped from a height of 20 meters. Find its velocity just before it hits the ground. Take g as 10 meter per second square. At the top, kinetic energy is equal to 0 because velocity is equal to 0. Potential energy is equal to mgh, which is equal to 2 times 10 times 20, which is equal to 400 joules. So the total mechanical energy of the system is 400 joules. According to the law of conservation of mechanical energy, total energy remains constant. At the ground, potential energy is equal to 0 since h is equal to 0. Therefore, kinetic energy is equal to 400 joules. Using the kinetic energy formula, half mv square, substitute the values. 400 is equal to half times 2 times v square. 400 is equal to v square. V is equal to 20 meter per second. The velocity just before the body hits the ground is 20 meter per second. Example 2. A 1 kilogram object is dropped from a height of 10 meters. Find its kinetic and potential energy when it has fallen a distance of 4 meters. G is equal to 10 meter per second square. Total energy possessed by the body at 10 meters height is potential energy, which is equal to mgh. 1 times 10 times 10 is equal to 100 joules. When it has fallen a distance of 4 meters, its distance above the ground is 6 meters. What is increasing? What is decreasing? Kinetic energy is increasing and potential energy is decreasing. At 6 meters above the ground, the potential energy is mgh, which is equal to 1 times 10 times 6, which is equal to 60 joules. Since total energy is constant, total energy is equal to potential energy plus kinetic energy. Substituting, 100 is equal to 60 plus kinetic energy. Kinetic energy is equal to 100 minus 60. Kinetic energy is equal to 40 joules. Final answer, kinetic energy is equal to 40 joules. Potential energy is equal to 60 joules. Example 3. A body is released from a height of 14 meters. At what height will the velocity be 8 meters per second? Take g as 10 meters per second square. When a body falls freely under gravity, as it falls, potential energy converts into kinetic energy. Total mechanical energy remains constant. So we use total energy at A is equal to total energy at B. At B, the body possesses both potential and kinetic energy. Let the height at which the velocity is 8 meters per second be hb. So total energy at A will be equal to potential energy at B plus kinetic energy at B. mgh is equal to mghb plus half mv square. The mass of the body is not given in this question. That will not be necessary. So we divide each term by m, the mass. The equation becomes gh is equal to ghb plus half v square. Substitute values. 10 times 14 is equal to 10 times hb plus half times 8 square. Simplifying, 140 is equal to 10 hb plus 32. 140 minus 32 is equal to 10 HB. 140 minus 32 will give 108. 108 is equal to 10 HB. HB is equal to 10.8 meters. Final answer. The velocity becomes 8 meters per second at a height of 10.8 meters above the ground. Notice that the body has only fallen 3.2 meters before reaching that speed. That's how to apply conservation of mechanical energy to solve motion problems. In ideal situation, no air resistance, mechanical energy is always conserved. This principle applies to falling bodies, pendulums, roller coaster, etc. See you in the next class.